session we are going to study deletion in linked list. So in the previous session we have discussed insertion in the linked list, and if you have watched that session then it will be very easy for you to understand this concept. But still, if you have not watched that session, I will try to make you understand all the concepts in the simpler language. So now let us start with this concept. So there are different ways of deletion in linked list. The first part is deletion from the beginning of the linked list. The second part is deletion from the end of the linked list. And the third part is deletion in the linked list at some specific position given by the user. So now let us start with the first part. The first part, as I have told you, this is deletion from the beginning of the linked list. So let's say this 7, 8, 9 is your linked list, and if I will show you this diagrammatically, so this is a linked list containing 7, 8, 9, and this 70, 80, 90 are the respective addresses of their nodes. So if after deletion, I will show you this linked list, after deletion from beginning, the linked list that you will be having is head. Now you can note that the first node of the linked list is this, and now after deletion from the beginning, this node will be deleted. So now this will be our first node. Now this 8 is our first node. The address stored here was 90. The address of this node was 80. So now the head will store the address 80, because now this is the first node, this is the deleted node. So this is not the first node now. So the next node is this 9. So this will be your linked list after deletion from the beginning. So now let us see the code that how can you delete from the beginning in the linked list. So we will be writing the function for this. So the name of the function to delete the node from the beginning is delete b, and the parameter to this function will be the head of the linked list. So this is node star head. So now before writing the code for this, let me make you understand the concept that we are going to use in this code. So how we will do this deletion? So for this deletion, I will make a pointer to this first node, and the name of this pointer will be temp. So I will be storing the address 70 in this node. How we are going to do this using code, I will tell you here, but let us understand the concept first. So the first step is we have made the pointer temp which is pointing to this first node. Now the next step is to break this particular link and make this link. How this can be done? This can be done using the idea of addresses, using the concept of addresses. We will remove the address 70 from here. Once you will remove the 70 address from here, this link will get broken, and now we will put the address 80 here. So now once you will put the address 80 here, that is you have put the address 80 at place of 70, then this link will be created at place of this. So once this link will be created, you can see that this is the first member of your linked list and this is the second member of your linked list. And once you have created this linked list, you will delete this particular node using the delete keyword. So now let me just write the code. If you have not understand the concept, then hopefully you will understand the concept from this code. So as I have told you, the first step is to create a node whose name is temp. This is the node pointer which is pointing towards the address where the head is pointing. And we have seen that earlier the head was pointing to the first node. So after this assignment, this temp will be pointing to the first node where the head was pointing earlier. I hope this is clear to you. Now as I have told you, the second step is to remove this address 70 and put address 80 here. So we will do it by assigning head is equal to head next node. So now let us focus on the structure of node first. So in the structure of node, the first part which is storing the value is named as data value, and the second part which is storing the address of the next node or the address of its successor, its name is next node. So this pointer name is which is storing the address is next node. So now earlier head was 70 and head was pointing to this. Now this is the data value and this is the next node pointer. So you can see that from here that earlier head was 70 and head's next node which is this is 80. So head next node is equal to 80. So since we want to remove 70 from here and we want to put 80 from 80 here, so I will assign head is equal to head next node value, head next node address which is 80 in this case. So with this assignment you will break this link and create this particular link that we want to do. So now this is our second step which is completed, and the third step, as I have told you, now this link is created, this particular linked list is created now after this link. So now the third step is to delete this node forever, because we don't want to keep this because this is not required at all now. So we will delete this and free our space so that this space can be used for something else. Now we will use the keyword delete here and we will write delete temp, because we know that this temp was pointing to this first node. So when you will write delete temp, then this particular node will be deleted and the space that was acquired by this will get free and it can be used for something else. So now I hope that this code is clear to you. So now let us move on to our second part, which is deletion in the linked list from AND. So before moving to this part, let me just tell you that here you need to pass this head by reference, not by value, because here you can see that here we are making changes in the head pointer. We have make our head pointer to point to this second node instead of this first node. We have broke this link and connect this particular link. So since we are doing the changes in our head pointer, we need to pass this by reference, not by value. So you need to mention this operator here so that you can do pass by reference. So now let us move on to the second part. So now deletion from the AND. So if this is our linked list, this is same as the linked list that we have taken earlier in our example. So now I have taken the same linked list for the explanation purpose here also. So this is our linked list earlier, and after deletion from AND, the linked list that we will be having is this. Here we have first node which is this. Now again the second node, and since this is deletion from the AND, So this last node, the node at the end of the linked list will get deleted. So now this node is get deleted. So here will be having the null pointer, because we know that at the last node of the linked list we have null pointer here. There would be no address, because now this node doesn't exist at all. So now here we will be having null pointer and it will be pointing to null. So now this will be the linked list after deletion from the AND. So now how we will perform this particular task in our code. So let me just first tell you that we will also make another function for this. The name of this function will be delete e, and the parameter of this function will be node star head. And let me just tell you that since here I am not going to make any changes in our head parameter, in our head pointer variable, therefore I'm not passing it by value, I'm not passing it by reference. So here pass by value and pass by reference, pass by reference, both will work. So you can do anything that you want, but in the previous case, as I have told you, we are changing our head pointer to point to this instead of this. So here we need to pass by reference only. So now I hope that this is clear to you. So now the strategy to delete this particular node is, we know that earlier our pointer was on this. We will bring our, earlier our head pointer was on this. Let me just name it something else. We will create a pointer whose name will be current, and we will set this pointer to this first. And now using a while loop, we will bring our pointer at the node, at the second last node. So the first step to delete the node from the AND in the linked list, you need to make a current pointer, a pointer whose name is current, and using the while loop you will bring this pointer, at the second last node. And once you have bring this pointer to the second last node, here you can see that this is the last node and this is the second last node. So now this current pointer is at the second last node. So once you have bring this current pointer at the second last node, you will break this particular link, and after breaking this link you will remove this 90 here and you will make it to point to null. And now we know that how can we break this link. So now this link was created here because here at the place of address you have stored the address 90, and 90 was address of this node. So due to this link was created. This started pointing to the address 90, which was this. Now to break this link and to make it to point to null, we will store null pointer here at place of 90. So this is what we need to do. So the first step is to make our current pointer to point to the second last node. And how you will do this? You will do this using the while loop. And the second step is to break this particular link and connect this to the null pointer. So these are the two simple steps that you can perform to delete node from the AND. So now let me just write the code. So now note that here I am writing an extra condition. Let me just write that and then I will explain you why I have written the extra condition here. So this is null pointer cout empty linked list. So this is the extra condition that I have written here. Now let me just explain you this condition. So let us believe that the head pointer that the user have given to you is not pointing to any address. So in the example that I have taken, this head pointer was pointing to the address 70, which is to this node. But now let's say there is a condition that the head pointer is pointing to the null pointer as I have taken here. Then it means that this is the empty linked list. There is no element in this linked list. So you can't delete any element. So you can't delete the last node because this doesn't have any node. So I have written here, you will print to your user that this is the empty linked list, and we will return from here. So this will be here. So we will print that this is the empty linked list, and we will return from here. So now let us just come on to our code. If this is not the empty linked list, then what we will do? So as I have told you, we need to make the current pointer. So let me just make an current pointer here. So node star current is equal to head. So with this code line, I have made my current pointer, which is pointing to the position where head is pointing. So you know that the head is pointing to the first node. So this current will also point to the first node initially. Now I will write a while loop so that I can move ahead my current pointer and bring it to the second last node. So for that I am writing a condition. Let me just first write it, then I will explain you. Current next node is not is equal to null pointer. So if it seems to you that this code you are not able to understand this code, then don't worry about it, because we will be also writing this code in the Visual Studio Code, where we will see the working of this code. So first I am explaining this code to you here on the paper. So here I have written this condition, and until this condition is true, we need to make our current pointer to move ahead by a step. So now you can note that if our current pointer is at this second last node, let me just draw this linked list clearly. So now if this is the second last node, and if current will be here, if current pointer will be here, then you can note that the current pointer is pointing here. This is the next node. Let's say it is storing the address 90 earlier, then it is storing the null pointer. The address of this node is 80. Yeah. So here we know that the current pointer is storing the address 80. And if I will talk about current's next node, then you can note that this is 90 here. If I will talk about current's next node to next node, so then you can note that this is pointing to the null pointer. Current's next node to next node is equal to null pointer. So this will be this condition will always be true when the current pointer is pointing to the second last node, because we know that the last node of the linked list always stores the address of null pointer, always points towards the null pointer. So current next node to next node will be equal to null pointer. So until this condition, until this current next nodes to next node doesn't become equal to null pointer, we will make our current pointer to move ahead by a step. and once it becomes connects next node to next node become equals to null pointer, then we will stop, because now we know that our current pointer has reached to the second last node. So after this loop will be completed, our current pointer will start pointing to the second last node. So now what is our next step? Next step is to delete this particular node and make this connection to the null pointer. So now here I will be deleting the current next node. So now you can note that the current next node was the address 90, and the address 90 was this last node which we need to delete. So after this code line, this node will get deleted, and then now the next step is, so now this node is getting deleted. Now the next step is to make this to point to null pointer. So now current next node, which is this, we need to make this null pointer. Now at place of 90, the node which we have just deleted, at place of this we will put null pointer here using this code line. So now you can note that once you have deleted this particular node and you have put null pointer here, then you will get this particular linked list that was required to us. So now with this code that we have written for the delete E function, we have performed the required task. So let me just write this code again clearly. So this is the code for the delete E function that we have just shown. So now let us move on to our. So deletion at some specific position given by the user. So now let us assume that the linked list given to you consists 4 elements, which is 7, 8, 9 and 10, and the addresses for the respective nodes is 70, 80, 90 and 100. So now let us say you are asked to delete the node at the third position. So let us say this is the first position, this is the second position, and this is the third position. So you need to delete the node at the third position. So after deletion, the linked list that you must have is, it will be head, and it will be first node which is 7. So here we will be having 7. Address is 80 again. This is 70. This is 88. This is 9. This is 18 address. And now you must note that this particular node is deleted. So this is our fourth node. Oh, so this is our third node because this particular node is deleted. So here we will be storing the address of this node at place of this. The address of this node is 90, which we were storing here earlier. But now since this node is deleted and this is our third node, so we will be storing 100 here. So 100 will be stored here, and the third node, as I have told you, is 10. This is 100, and this is null pointer again. This is pointing to null. So this will be our linked list after deletion. So how can we perform this? So to perform this using the code, we will be using a pointer previous, and we will set this pointer, we will bring this pointer before the node which we need to delete. That is, if I want to delete the node at the nth position, then I will bring this previous node at the n minus 1th position. So if I want to delete the node at the third position, so the n minus 1 position, which is 3 minus 1 is equal to 2, that is the position just before this. So I will bring the previous node pointer here. So how you will bring this? We will bring this using a for loop. I will tell you that how can you bring this. And if you have watched my previous session where we have discussed the insertion at specific position, then there we have performed the same task. So the code will be quite similar, but I will still explain you. If you have not understand there, then you will understand that concept here definitely. So as I have told you, the first step is to bring the previous pointer here. So note that this is the first step, to bring the previous pointer at the n minus 1th position. The second step is to make a to delete name pointer. The name of this pointer is to delete, and this will be pointing to the node which we need to delete. That is the next node of previous, because we know that we have set our previous pointer here before the node which we want to delete. And as I have told you, this is a, if this is a node, so this is a data value, and this is the next node pointer, and the previous next node pointer is pointing to this. So previous next node is the node which we want to delete. So I have made another pointer whose name is to delete, which is pointing to this. And now what we will do, we will just remove this address here. What we will do, because I know that here at place of 90 I need to put 100, because you can see from here, once we have deleted this node, then at place of 90, so this was 8 and 90, 8 was the value, 90 was the address of the next node. So here 8 is the value and 100 is the address of the next node. So here I need to put the address of this part is this node who is next to this. So in this case the address is 100. So previous next node. So we know that the previous next node was storing the address 90 earlier. This is the next node, previous next node. I need to put 100 here. So I will assign the address 100 to it. How can I assign it? I note that this is the to delete. This is the to delete pointer pointing to this now. And this next node part of to delete is storing address 100. So I will do to delete next node. After this particular assignment, this link will be broken and this particular link will be created, because now here the address 90 is not stored, here 100 is stored. So the link with the 90 will be broken and the link with the 100, the link with the node at the 100th address will be created with this assignment. So we have created this particular link and broken this link. So now the next step is to delete this node. We can just do it using the delete keyword in the C++ language, which is delete, to delete. Because we know that to delete pointer is pointing to this node which we want to delete. So once we will write delete to delete node, so after that this particular node will get created. So now let us see the full code for this deletion. Now in that code we will put some extra condition, which I will explain you that why I have put that condition there. So now let us move on to this code of this particular part. Again, the name of the function is void. The type of this function, return type is void, and the name is delete between and the parameter to this function is the head of the linked list, and here I will be passing the passing this head by reference. I will tell you why I have passed this by reference. Now after this I will be passing the next parameter as the position, the position which I want to delete in the linked list. So now first I will add the same condition which I have written in the delete E, that is, if head is a null pointer, if head is a null pointer, then it means that you have empty linked list. We have empty linked list. There is no element in the linked list, so we can't delete any element, so we will return from here. We can't delete any element. The second condition is if user, now we know that we are using the concept of previous, and let's say if user want us to delete the first node, then we can't use our concept, because we know that the previous was pointing to the node, the pointer previous was pointing to the node before the given position. As we have seen that if we want to delete nth node, then previous was pointing to n minus 1th node. But here if user will pass the index 1 that we want to delete the node at the first position, then we can't use the concept of previous. So in that situation what I need to do, because there is no node exists before this n is equal to first node, so we can't use the concept of previous here. So if the position that the user has given 1, then we will call the function delete b, because we know that if the position is 1, then the user want to delete the node from the beginning, so we will call this function and we will pass the head to it. So now from here itself it will be clear to you why I have passed the head by reference, because in the delete b function, as we have seen, we need to pass the head by reference. Therefore if I want to use head here in the delete b function, here I need to pass the head by reference. So this is, so I hope that these both condition is clear to you. Now I will write a loop, because I know that I want to take the previous pointer to the n minus 1th position. So let me just create the previous pointer first. Initially previous pointer will be pointing to the first node, which we will do by this assignment. And now you will now it should be clear to you that why after this assignment previous will be pointing to the first node. So now the loop is for int I is equal to 1 until I is less than n minus 1 I plus plus I plus plus. We need to do what? We need to make previous a step forward. So now here again I need to mention some other condition. So let me just first write that condition, then I will explain you. If previous next node is equal to null pointer, then print that position is out of bounds and return from this loop, return from this function. So now why I have written this extra condition, because there is some possibility that, let's say, your linked list consists of 4 members and the user is asking you to delete the 5th node. So when you will bring your previous pointer before that previous node, so you will see that if your previous pointer will reach here, then at this particular stage the next node part. As we have seen that this is a data value part, this is the next node part. The next node part of the previous pointer becomes null. As soon as the next node part of previous pointer become null, then it means that we have reached to and off linked list, and we can't move ahead, and the position that the user is asking us to delete is not present in the linked list, or we can say the position given is out of bound. So now I hope that this condition is also clear to you. This condition is itself ensuring that if the position given by the user is out of bound, that is, that position doesn't exist in the doesn't exist in the linked list. Like if the position is given greater than 4 in this particular case, as we have seen, in this particular case the length of linked list is 4. If user will give any position greater than 4, that is 5, 6 and 7, then we need to print that position is out of bound, and we need to return from this function, since deletion can't be performed now. Now I hope that this is clear to you. So now after this loop will be completed, the previous pointer will be pointing to the n-1th node. So once the previous pointer will start pointing to the n-1th node, as I have told you, we will create another pointer whose name will be to delete, and it will be pointing to the previous next node, as I have told you just now earlier before this code on the previous page. And once it is done, what we will do, we will assign previous next node the address stored in the to delete next node, and after this we will delete the node pointed by the pointer to delete. So now I hope that this particular code is clear to you. Here we have just added some condition. The first condition was checking that is the list given to us have elements or not. If it doesn't have any element, then we will print that the list given to us is empty, and we will return from here. And if position is equal to 1, we will call the delete b function for this, because we know that now our approach for this delete between function was using the concept of previous, which will not work for this position equal to 1. So we will call this delete b function for this. And after this I have created a previous pointer which is pointing to the first element first initially, and after this for loop, with the help of this for loop, I have brought my previous pointer to the n-1th position, and in this particular condition I have checked that is the position given by the user present in the linked list or not. If the position is not present in the linked list, that if it is out of bound, then we will print that the position is out of bound, and we will return from this function. And after this, once we have finished from this loop and the previous pointer has reached the n-1th position, then as I've told you, we will make a to delete node, and these 3 steps I have explained you earlier. Then we will perform these 3 steps, and after this we will be able to perform the task given to us. Now I hope that this function is also clear to you. So now let us move on to the Visual Studio Code and see the working of these functions there. So here, as per the explanation, I have written the code for the delete b function, delete e function, and this delete between function. And here I have created the linked list 5, 8, 50 and 60, And with the help of the traverse linked list function, we are traversing the elements of our linked list. So if you have any confusion in the creation and traversal of linked list, then you must watch our session on creation and traversal of linked list. In this session, we will be focusing strictly on deletion of nodes. So as I have told you, this is the linked list that we have created, which is 5, 8, 50 and 60. And now we will be testing our delete functions. So the first call that I'm going to do is for the delete between function, and using this delete between function I am deleting the node which is present at the third position of the linked list. So now let me just run this code. So this is the linked list before any deletion, and this is the linked list after deleting the node at the third position. So here you can see that earlier the node that was on the third position was 50, and now this node 50 is deleted from this linked list after the call for this delete between function. So it means that this function is working properly. So now let us test our other functions. So now I am calling the delete b function, and now I will be running this code. So here you can see that the linked list before any deletion was 5, 8, 50 and 60, and after a call from the delete b function, the node from the beginning has been deleted. So the linked list that I have now is 8, 50 and 60. So as you can see that the beginning node, which is 5, has been deleted now. So this particular function is also working properly. So now let me just check the other function, which is delete function. So now here you can see that again from my linked list, which was 5, 8, 50 and 60, the last node, which is 60, has been deleted from the linked list, and the linked list after deletion of the last node is 5, 8 and 50. So all these three functions are working properly. So now I hope that all these things is clear to you. So we will end our session here. So see you in the next session.